The classic childhood science fair experiment that mixed vinegar, which is HC2H3O2, and baking soda is an acid-base reaction. Which reactant is considered the base? Well, let's look at these two reactants up here. Okay, there's vinegar. Notice that here you have a hydrogen. Over here, the hydrogen left. So by the Bronsted-Lowry definition, this is an acid. So since the question, which one of these is a base, well, it has to be the baking soda here. Now, it looks like this also lost a hydrogen, but it really didn't, because that HCO3 is decomposing into carbon dioxide and water. So this is your base, and the vinegar is the acid. Identifying reaction types. One can determine the type of chemical reaction by following some basic guidelines. Number one, is there a precipitate? What you're looking for there is the formation of an insoluble solid. That's that little subscript we have, S. Check to see if H+ ions are being transferred. If so, you have an acid-base reaction. Check the oxidation states. If they change, we have an oxidation-reduction reaction. What kind of reaction is the following? We have butene over here, looked it up on the web, plus oxygen gives carbon dioxide and water. And there's several steps. Is there a precipitate? Is there a transfer of H+ ions? And check the oxidation states. We will do that on the next slide, but give it a shot yourself before you move on. Hopefully you had some success with this, but let's go through it now. First of all, did you notice that we didn't really balance this? This is not a balanced equation, but we don't need it here to determine what type of reaction we have. So that'd be a nice exercise. Go off and balance this. But let's start. Is there a precipitate? Nope. You have gases over here on the right, not a precipitation reaction. Is there a transfer of hydrogen plus ions? No, that's not happening either, so it's not acid-base. Check the oxidation states. We have hydrogen here 8, so 8 times 1 would be +8, and carbon is -2, so that gives us a -8, so that checks. So carbon goes from -2, and what do we have over here? Oxygen, 2 times a -2 is -4, which means carbon in this case is +4. So it looks like carbon is going from -2 to +4, so that's oxidation. Let's see what happens to the oxygen. It's 0 over here, then over here on the right side it's -2 in both cases, so it's being reduced. So we have an oxidation-reduction reaction. What type of chemical reaction is the following? Magnesium plus hydroxide gives you magnesium dihydroxide. Here's the key right here. It's the first guideline. Is there a solid precipitate forming? Yep, you see the S. So what kind of reaction do we have? Precipitation.